Hi everyone. So a quick lesson on trigonometric equations from the beginning. Before we actually start into solving trig equations, we're going to need to do a little bit of recall. Let's take a look at a 30, 60, 90 right triangle right here. If we want to find the tangent of 30 degrees, that means we are going to use an angle of focus over here. And that means this is the opposite side, and that means over here is the adjacent side, which will make the tangent of 30 degrees equal to 1 over radical 3. And if we are then changing our focus from 30 over to 60, like we do here, like we need to here for the sine of 60 and the cosine of 60 degrees, that means our opposite and adjacent labels are going to swap. Hypotenuse, though, is going to remain the same throughout, regardless of where your angle of focus or reference angle is located. So that means the sine of 60, opposite over hypotenuse, is equal to radical 3 over 2. And the cosine of 60, adjacent over hypotenuse, is equal to 1 over 2. Now, on the other side here, numbers 4, 5, and 6, we'll start with number 4. This is an inverse trig function. And what this means is that, really, when you solve a trig function here like this, tangent of 30, right, what is going inside of here is the measure of an angle. Whether it's 30 or pi over 6 or x, this is the representation of an angle measure. And what you get out here is just a number value. Right? It's got no units associated with it, but it is a number value. And when we use this notation that looks like tangent raised to the power of -1, this stands for the inverse tangent sine cosine function, right, that we see over here. It is not an exponent. It is just simply a way of writing down the inverse function. And what this inverse function does is reverses the number or the angle and the number value. So when you write down an inverse trig function, what you're writing inside the parentheses is a number value, and then what you are solving for is an angle. So these two here, numbers 1 and 4, are related in that they are kind of reversed. You can swap the value to go inside and the angle to come out as an answer. And that's very simply a very simplistic view of what an inverse trig function is. So if we want to find the inverse sine of radical 3 over 2, since sine of 60 is equal to radical 3 over 2, that means the inverse sine of radical 3 over 2 is equal to 60. And the cosine of 60 equals 1/2, which means that the inverse cosine is going to work the same way. The inverse cosine of 1/2 is equal to 60 degrees. Now, we have used inverse trig functions before, and we have used them in the context of a right triangle such as this. Right? If we wanted to, let's say here, find the measure of angle B, we can put we can focus up here and then recognize that 1 is the opposite side and radical 2 is the hypotenuse, which will tell us that we can use the inverse sine function, right? Because if we know, actually, before I do that, if the sine of this measure, angle B, is equal to opposite over hypotenuse, 1 over radical 2, that means we can use the inverse sine function, place that value inside the parentheses, and then come up with a measure of an angle. And we can use our calculator to do that. We will type in the inverse sine function. You should be able to type it into your calculator. And come up with x equals 45 degrees. Make sure your calculator is in degrees mode. So this is a 45-degree angle over here. If we jump over, let's say, to a later problem that we did more recently, which is finding the sine of 120 degrees, for instance. And you know what? Yeah, let's find the sine of 120 degrees here. Right, so what we're doing here is drawing an angle that will start at the initial, swing over past 90, but stop before 180 degrees. This is a 120 degree angle over here, right? Which means that we have in here a reference angle. And this reference angle is going to measure 180 degrees, which is the entire piece, minus this 120, so we can find just this piece in red over here. So 180 minus 120 is equal to 60. We can then use our knowledge of right triangles, and we can draw a perpendicular line towards the x-axis, which will create a right triangle in here. I'll draw it again, which will create what we have here, which is in the second quadrant, Q2, a right triangle that contains not the 120 degree angle, but this reference angle of 60 degrees. That makes this to be a 30, 60, 90 right triangle. That makes the hypotenuse measure 2. That makes the vertical side opposite 60 degrees, measure radical 3. That makes the bottom side opposite 30 degrees, measure 1. So if we're looking for the sine of 120 degrees, what we are doing instead is using a reference angle of 60 degrees in place of this 120 degree angle. And since the sine function is positive in the second quadrant, that means this is going to remain positive, and we can use opposite over hypotenuse here, back to our SOHCAHTOA, and we get radical 3 over 2 as our answer. So remember, back in a couple of minutes ago, what is the inverse sine function again? The inverse sine function again takes a value like this, radical 3 over 2. And we can put in this angle as the answer. The inverse sine of radical 3 over 2 is equal to 120. The inverse sine, so the sine of 120 is equal to radical 3 over 2, which means once again we can swap these two values. But take a look at what we did 2 pages ago. We found that the sine of 60 was radical 3 over 2 based on this triangle, which means we found that the inverse sine of radical 3 over 2 was equal to 60. So the inverse sine, I'll write it again, radical 3 over 2 is equal to 60, right? It kind of says it over here also. How? How is the inverse sine of radical 3 over 2 equal to both 120 and 60 degrees? Well, that happens because of the way that trigonometry is set up, right? I mean, that's, again, I'm not going to dive too deep into that, other than the fact that you do need to be able to recognize these duplicate answers, and they're visual on the unit circle, right? Because when you find the sine of 60 degrees, we're finding basically, remember what the unit circle represents is a circle with a radius of 1, centered at the origin, and all of these ordered pairs along this edge. All of these ordered pairs, of which there are an infinite number of pairs, but a select few of special ordered pairs. This is one of those special ordered pairs, 1 over 2 comma radical 3 over 2. And what this represents is that this y value represents the sine of the associated angle that intersects that point on the unit circle. So that means that the sine of 60 degrees is equal to radical 3 over 2 according to the unit circle. Now, is there another place on the unit circle that has a y value of exactly radical 3 over 2? Right over here we see an x value of that same number. Over here we see a y value, but that's negative. If we go over to the second quadrant, let's do this in a separate color. If we go over to the second quadrant, we can see that a y value of positive radical 3 over 2 exists over here at 120 degrees. So if there's an angle, again, starts at the same place as before, which is the positive x-axis, but this angle instead swings over to 120 degrees, past 60, past 90, stops at 120. That means that the sine of this angle, 120, is going to have the same answer, right? It's going to have the same value associated with it, radical 3 over 2. And you see this all over the unit circle, right? You can see duplicate answers all over the place. For instance, the cosine of 30 is equal to radical 3 over 2. The cosine of 330 is also equal to radical 3 over 2. The cosine of 210, or sorry, let's go with this. The cosine of 225 is equal to negative radical 2 over 2. The cosine of 135 is also equal to that same value. And you're going to see repeat answers at the tangent function too. Even though the unit circle doesn't say the tangent function, there are going to be repeat answers, right? The tangent of 45 degrees, remember tangent's equal to sine over cosine, right? Something that you're going to need to remember in a little bit. But you can take the sine function, divide the cosine function to get the tangent function. Radical 2 over 2 divided by radical 2 over 2 is equal to 1. Again, so is there any place else on the unit circle where the sine and cosine values essentially are the same, which means they will divide out to be equal to 1? The answer is yes. Down here, we just have the same sine and cosine values. In this case, they're both negative, but negative over negative is a positive. So you are seeing repeat answers for the tangent function as well as the sine and cosine function. So since we are not working within right triangles, right, this kind of duplicate answers is not a problem on this here. And the reason is because we are working exclusively within a right triangle. We're trying to find the measure of this angle. Now, is it possible that this angle A is equal to 90 degrees, and then maybe X is equal to 135? Because according to this, the inverse sine of 1 over radical 2 is equal to 45 degrees, but it's also equal to 135 degrees. All right, and that's evident over here. The cosine, or radical 2 over 2 is the same as 1 over radical 2. So over here we have a sine function that equals radical 2 over 2. Over here we have a sine function that's 135 degrees. We'll figure out how to get all of these answers in a bit. But now I'm more concerned about how you are able to determine whether you need to find these duplicate answers or not. If you're working within a right triangle, A is 90 degrees, then B is impossible to be 135. Right? That's going to add up to over 90 degrees with two angles alone. Over 180, sorry, with only two angles, leaving no room for the third angle to be of any size. So that is impossible, right? That's why the answer here is 45 degrees and only 45. But now if you are working within a space that does not have those kinds of restrictions, that means the inverse sine of radical 3 over 2 can equal 60, can equal 120, can equal maybe 420 degrees, which is a coterminal angle. An angle that spins 420 degrees ends up intersecting the unit circle in the same location as a 60-degree angle. So now there are multiple answers. For this class, we will disregard the answers that are past 360 we will disregard, well, we will learn how to deal with answers that are maybe negative, because a negative 300-degree angle, again, will end up in the same place. So what about the inverse cosine of 1 over 2? Right, we got 60 degrees there. And are we automatically going to look at 120 for the inverse cosine? Well, take a look. At 120, that cosine function is equal to negative 1 over 2, not the same thing. So we need to look in the fourth quadrant at a 300-degree angle to find the second answer. And what about tangent? Tangent is equal to 1 over radical 3. We got that this is equal to 30 degrees. Notice that all of these denominators are equal to 2. So in order to find a tangent function, you have to place sine over cosine. 1 over radical 3 is the tangent function, the tangent value we're looking for. Right? If we look at this, again, you have to put y over x, essentially. The radical 3 over 1 is not the same thing. Where else are we going to see a positive 1 over radical 3? That's going to be right over here. Negative 1 over negative radical 3 is equal to a positive 1 over radical 3. So we're going to see 210 degrees as the second answer. Right? Again, this is not that it's incorrect, not needed for now. So your homework is going to ask for answers in different ways, right? It could ask for what's called the principal root, which is essentially just the first answer, the answer that comes from your calculator, right? Your calculator can give you a principal root. Just make sure that your calculator is in degrees mode. Make sure that you are typing it in correctly. And make sure that you were using the inverse trig function, not the regular trig function. And your answer can also be placed within a range of, this means x is an element of 0 to 360 degrees. That means it can be at lowest 0 and at most 360, right? And what you're doing is finding all of the angles that satisfy this answer. Right, all of the angles where the sine function is equal to radical 3 over 2. And in that case, there's going to be two answers here, 60 degrees and 120 degrees, that both satisfy that answer. Where is the cosine function equal to 1/2? Well, that's also two answers, 60 degrees and 300 degrees. And your answers can also be given, asked for x is an element from 0 to 2 pi. That's the same exact values, just turned into radians. So make sure your calculator is in degrees. And we're going to figure out how to find all our answers in degrees and then use that as an intermediary step to get to radians. So we can use our conversion. And then it's possible that these angles, these equations that we're going to be solving, can ask for all solutions, every solution possible, of which there will be an infinite number. So the way we can do that is by finding the measure of an angle, call it x1, and then declaring that we can add or subtract full revolutions of a circle to that. So that would be, for instance, 60 degrees plus or minus 360n, right? That means 60 degrees, that means 420, and plus 60 plus 360 or whatever. And also negative 300, negative 660, and then minus, and then minus. And again, there's an infinite number of angles there. And x2 will be based on the second answer that comes out of here. And again, plus or minus 360n. If you're going to need to do this in radians, then you can take your x1 in radians and then add plus or minus 2 pi n, right? And all of this is under the assumption, or not assumption, but the declaration that n is a positive whole number. N is equal to 1, 2, 3, ... Okay? In this class, we will focus on getting our answers really in radians between 0 and 2 pi. Right? Also, the principal root is something that some questions will ask for. So let's take a look at this. Let's solve for this equation here. This says 2 sine x equals 1. All right, now the first thing you want to do is isolate your trig function. Right, you want to isolate your trig function. You know what? I'll write this on a separate piece of paper. Right, so the first thing you want to do is isolate your trig function. Now, on this step, you are essentially treating your trig function as a variable. Right, if you are able to solve an equation 2x equals 1, I think hopefully it's pretty evident that in order to solve for x, you need to divide by 2 on both sides. Right, and you're going to do the same thing here on this trig function, treating the sine of x as your algebraic variable. So divide by 2 on both sides, and that means that the sine of x is equal to 1 over 2. All right, so same principle as solving this equation right over there. So after you have isolated your trig function and essentially solved for your trig function, the next step is going to be to use inverse trig function to find x1. Right, I'm going to call it x1 because, again, we are going to expect multiple answers. So we're going to have the sine inverse of 1 over 2, and we're going to call this equal to x1. We can use our calculator. Again, type in. I'm not going to show the calculator for any kind of copyright purposes, but we can use our calculator, the inverse sine of 1 over 2. You can type that in. And x1, in this case, is going to equal 30 degrees. Right, again, your calculator should be in degrees mode, so your answer should be 30. If you were getting a decimal answer in this case, that means your calculator is probably in radians. And let's take a look. Remember when we did what was called ASTC, all students take calculus, right? ASTC, right? That means as far as the sine function is concerned, because we are using the sine function for this equation, so we're not really concerned about cosine or tangent right now. So for the sine function is positive in quadrants 1 and 2 and negative in quadrants 3 and 4. So that means that x2, our second answer, since 1 over 2 is a positive number, right, that means we already got our answer in the first quadrant. That was 30 degrees from our calculator. That means our second answer has to be located here in the second quadrant. So if we look at a 30-degree reference angle in the second quadrant, that means 180 minus 30 is going to equal 150 degrees. Right, so this answer that we got from our calculator, that is the principal root. So if your problem asks for the principal root, that means you only need to provide this 30-degree angle and you're done, you're finished. Right? If your question, if your trig equation asks for answers to be in an element from 0 to 360 degrees, that means that your answer is going to be x1 is equal to 30, x2 is equal to 150. These are going to be your two answers if you need to present your answers in degrees from 0 to 360. If you need to present your answers in radians from 0 to 2 pi, again, all answers, that means what we're going to do is take 30 degrees and multiply by pi over 180. We're going to take 150 degrees multiplied by pi over 180. 30 and 180 are both divisible by 30. So our answer is equal to pi over 6. 150 and 180 are also divisible by 30. 5 up top, 6 on bottom. So our answer for the second is equal to 5 pi over 6. It is very important that you read the directions on how your answer is to be presented. Because that's going to be the difference on whether you get a question right or wrong on web work, even though all of this work is correct. Okay? I will reiterate once again. If the problem asks for the principal root to be given as the answer, then all you need to provide is this one single answer. If the problem asks for all angles within 0 to 360 degrees, then you're going to need to do something here to find a second angle and then provide both of those answers. If those answers have to be in radians, because it says 0 to 2 pi as the range, that means you got to take these two angles and convert them both into radians, multiplying by pi over 180 in order to do so. So in this case, pi over 6 and 5 pi over 6. Let's look at another one. Number 2, it says tangent x plus radical 3 equals 0, right? Looks a little hairy because there's a radical 3, but in reality, once again, this is the same principle as solving x plus 7 is equal to 0 in an algebraic sense, right? We subtract 7 from both sides, x is equal to negative 7. So if we were to solve this, we're going to subtract this constant value of radical 3 and then end up with tangent of x equals negative radical 3. Now we can use the inverse tangent because we know what the tangent of this angle is equal to. This allows us to use the inverse tangent of negative radical 3 in order to come up with an answer. X1 is equal to what our calculator says, which is negative 60 degrees. So I didn't finish those steps, right? Use the inverse trig function to find x. And then the third step is to find alternate answers, right? It's actually it's possible to not have two answers, right? Sometimes the trig function only has one answer, but you do have to go through the steps. In a case where a trig function only has a single answer, that means that you did the proper steps and both answers turned out the same, right? The last step, present answers, again, may be 1 or 2 or 3 or 4 according to the directions you were given, right? So whatever directions you were given, make sure that you are following those directions to present your answers. So let's look at this. When you type in inverse tangent of negative radical 3 into a calculator, you're going to get this negative angle, right? It's going to say negative 60. Now what this means is that this is an angle that measures negative 60 degrees. So this, again, straight from your calculator, this is your principal root. But if you are being asked to present your answers in a range from 0 to 360, that means that x1, our answer here, has to be adjusted by finding the coterminal angle, add 360 degrees to get 300 degrees as your x1. So what about x2? Remember, on a tangent function, all students take calculus. Tangent function is positive in quadrants 1 and 3, and it's negative in quadrants 3 and 4. Right? So that means that this value here, tangent of x equals this number, or the inverse tangent of this number, is either going to be positive or negative, and that's going to kind of depend on on whatever number it is. Right? Our first answer is in the fourth quadrant. Our first answer is in quadrant number 4. That's 300 degrees. In order to find the second answer on a tangent function, we're going to take 180, in this case, plus our first answer, negative 60. And that's equal to 120 degrees, which puts us in the second quadrant. So that's our two answers in degrees, right? Which covers part B. Again, follow those directions. If we need to convert these into radians, we can convert them into radians. 300 times pi over 180 and 120 times pi over 180. We can divide here by 60 to get 5 over 3. So that means 5 pi over 3 radians here. We can divide by 60 over here, 2 up top, 3 on bottom, and 2 pi over 3 is our radian equivalent of 300 and 120. One more. 2 cosine x equals negative 1. Again, solve for our trig function. In this case, divide by 2. Cosine of x equals negative 1/2. Inverse cosine of negative 1/2 is going to equal x1. So A, straight from our calculator, oh, this is, sorry, I'm sorry. I wanted this not to be a 2. Let's start over. I wanted this to be a radical 2 cosine x, right? So radical 2 times the cosine of x. Divide by radical 2. We can divide by this constant number. Cosine of x is equal to negative 1 over radical 2. The inverse cosine, rather, then. Be careful typing in these radicals and fractions into your calculator. It can get a little hairy. Make sure that you're typing it in correctly to get the correct answer. So part A, x1 is going to equal 135 degrees. So remember, in the last problem we typed in negative, we typed in that negative radical 3, we got a negative angle. Here we're typing in a negative, but we're still getting a positive angle from the cosine function. So, not all trig functions are going to give you negative angles. It's the sine and tangent functions that will. And anytime you get a negative principal root, then you should adjust it by finding a coterminal angle. But we don't need to here because it's already positive. That means x1 is going to equal 135. And that means x2 is going to equal, for a cosine function, again, if we're concerned only about a cosine function, positive in quadrants 1 and 4, negative in quadrants 2 and 3. 135 is in the second quadrant, once again, because this was a negative answer over here. That means our other answer is supposed to be in the third quadrant. Let's see if that happens. 360 minus 135 is equal to 225, a third quadrant angle. So 135 and 225 is our answers from 0 to 360 degrees. Converting into radians to figure out part C. we can take 135 and divide by 45 to get 3 up top, 4 on bottom. So 3 pi over 4 radians. Divide by 45 once again. 4 is on bottom. 225 divided by 45 is equal to 5. And this is equal to 5 pi over 4. So again, our radian equivalent of 135, 225 is going to be 3 pi over 4, 5 pi over 4 radians. To sum up, when you solve your trig equation, your first answer you can use your calculator for. And that's good. You're going to be typing in your inverse trig function, either inverse sine, inverse cosine, inverse tangent. And if your calculator produces a negative angle as an answer, don't worry. That's normal. You know, a sine function and a tangent function can give you those answers. Cosine cannot. It's just the nature of the way it is. But if that happens, then add 360 to it to give you a new x1 that is within range. Again, a principal root, though, can be negative. A principal root can be negative 45, negative 60, negative 30 degrees. That's fine. And your second answer, that's going to be needed if you need to provide an answer between 0 and 360 or 0 and 2 pi, is going to depend on which trig function this equation is using. Right? There are some trig equations that we solve on another video that have multiple trig functions in it. In that case, you'll be using, maybe sine and tangent or something like that, but one at a time. So if you use the sine function to get your first answer, that means 180 minus that principal root is going to get you the second answer. If you used a cosine function to get the first answer, 360 minus your principal is going to get you the second. Tangent function, 180 plus x1 to get that second answer. All right, so hopefully this was helpful, and I will see you soon.